To go.
All right, good. Hello and welcome everybody. Thank you for joining another webinar by Lachisoft. My name is Nick Zulfikar. I'm the Director of Client Services here. With me is my colleague Cal Ali. He's our Senior Solution Specialist. He's the subject matter expert for all things distributed caching here. He's going to be doing the technical presentation today. We have a very exciting topic. It's about how to scale your ASP.NET SignalR applications using a distributed cache. As you all know, SignalR is primarily used for real-time push notifications over the web applications such as chat, real-time tickers, sensor monitoring, etc. uses it. So in today's live webinar, we're going to be talking about how using NCache's Backplane you can use to scale your applications using SignalR. So with that, I'm going to hand it over to Cal. He's going to take us through the presentation. If there are any questions during the presentation, kindly type them in the questions box on the right-hand side of the screen, and I'll be able to ask those for you. Thanks. Cal, kindly take over, please.
All right, thank you. Hi guys, as Nick just introduced, my name is Cal and I will be your presenter for today. I'm going to start with the webinar now. So the topic of today's webinar is scaling ASP.NET SignalR apps. So today we will be talking about SignalR as a technology, how and where it is a possible candidate to be used within your applications, and what are the issues that are seen, especially in the case of when you introduce the backplane into the scenario, and what are the possible options that you have, and how you can basically work around those. So I'm going to be covering all those different things, and as a sample product I'll be using NCache. So we'll get to that part later on. Initially we'll just cover some basic theory there. So let's get down to the actual introduction to SignalR. So these are some bit of the definitions that I've copied from the Microsoft documentation. So what is SignalR? SignalR is basically an open source library that developers can use to introduce real-time web functionality within your applications, ASP.NET applications. So let me give you an example to explain how and what exactly I mean here. So for example, you have a user who is accessing a web page, and he or she has a certain bit of data that's present on the page. But if that data needs to be fresh, or if the user wants to get an updated data, in normal scenarios the user either has to refresh the page basically, and the user has to send a request, and then in the response to that the updated data is received. Either this, or there has to be some long polling that needs to be implemented in the back. But if you have SignalR, this would not be required, and I'm going to get to those details later on. And this is one of the very good use cases where SignalR is a very good candidate. So secondly, SignalR gives you the ability to have server code push content right to the client side. So basically the part where the client has to send a request to get the updated data is it does not need to be, it's not necessary to be present anymore. So basically your all the clients actually connected to the web server would get updated data as soon as there's some new data within the server. So the server does not have to wait for the client to actually request for new data. The data would automatically be updated on the client end. Thirdly, so the best thing about SignalR is that it exposes the functionality to you. So you just need to introduce the SignalR resources within your application, and you need to call some specific functions, and everything else is handled by SignalR. So your application would be using SignalR to send messages from, for example, clients to servers, and from servers to client, whichever your scenario is. And everything else, and by everything else I mean the transport layer, how the message gets transferred, how it is notified, everything else is taken care by the SignalR logic. So you don't need to do it within your application. You just need to introduce these APIs within your application, and everything else is automatically handled by SignalR. So in this diagram, if you can see right here, I'm just going to give you an example. So within SignalR, there's a concept of a hub. So in this diagram right here, we can see that the server, this is a web server, and this is a connected client. It can be an HTML or JavaScript client. So this server is able to call this function myClient.func on the client end right here. And vice versa, if you look at this diagram, the client is able to call this specific function, function on the server end. So basically with HTTP, we all know it's a stateless protocol. There's a request and then there's a response, and there's nothing else that remains. Everything else gets removed. But with SignalR, what happens is that underneath, SignalR uses a WebSocket to maintain connections. So these are for the newer technologies, but in the older ones, they use the normal and the basic ones. But it uses the concept of WebSockets, to which it is able to invoke functions either from the server to the client end, and then from the client to the server end. Depends on how it is done. So let me explain some general use cases for SignalR. So the first one is a chat system. This is also a sample project which is shared by Microsoft themselves, and in my demonstration as well, I'll be using a chat system provided by Microsoft, and I'll have NCache integrated with it. But let's get back to the examples right here. So chat system. Here you need real-time messages that need to be sent. So for example, if you have a group where there are a number of members present within the group, and if any of the members sends a message, that message notification needs to be received by all the members of the group, and it needs to be done instantaneously. There is a delay of any sort cannot be afforded. And same case with gaming industry. So for example, you have online multiplayer games where a lot of syncing needs to be done, because there are a lot of players playing at in the very same session together, and the details of the game need to be synced with all of them. Third use case is, for example, airline booking system. So if a ticket or a specific seat has been booked, all the other people or all the other users which are currently viewing that specific data need to be notified that this specific ticket or this specific seat is already booked and cannot be booked anymore. Similar examples of stocks, because they're constantly changing, the values are going up and they're going down, so they need to be updated on the client end pretty quickly, and it is a really good requirement. Another one is second screen content, which can be ads or any sort of other notifications that need to be shown. And then finally, there's Internet of Things. So you have so basically these devices are constantly gathering some bit of data, they're analyzing it, they're throwing some notifications. So all these things need a certain sort of reliability, as well as there's an urgency for these to be received on to the receivers. So all of these use cases are pretty good scenarios where SignalR can be used, and generally, if talking about today, it is actually being used right now. So if I could just go to the next slide. And guys, if you, in between, if you have any questions, you can always jump in, and Nick would let me know if there's a question, and I'll be happy to answer you. So let's talk about scaling out SignalR apps. So if you look at this example right here, and this example basically shows that you have a web farm. It could also be a web garden, but I'm giving the example with a web farm. So you have a web farm here where you have a number of web servers here, and you have a load balance in between, which is rerouting all the requests that are coming in to all the web servers that are present within your web farm. And then you have all these different clients. So these clients, they would be connected to any of the web servers within the web farm. So if you take this example right here, client A is connected to this web server, and client B is connected to this web server, and client C is connected to this web server. So the issue here is that, for example, if this web server needs to send a message, it needs to send any sort of message or notification, it will only be able to send that notification to its specific connected clients. And in this case, if this client A is sending out a message, it would only be received by the connected clients to this web server, and in this case it's only one. So what if that there's a group chat that is going on between these three clients, and they would be connected to three different web servers, right? So if one of the clients sends a message, the other clients would not be able to receive this message in this specific scenario, because only the clients connected to a specific web server would be able to receive that notification. So in this case, it is limited as to only the connected clients to the web server are able to receive this notification. And in order to get rid of this, SignalR introduced a SignalR a term with the name SignalR Backplane. And let me explain what this is exactly. So if you take the same example, but a little bit of a different scenario, you have a web farm right here, and you have a load balancer in between. Let's assume that, and all the clients' requests are coming in through that load balancer and coming to their respective web servers. So in this case right here, there's a shared bus, there's a shared repository which is connected to all the web servers present within the web farm right here. So if you have, let's assume that you have 10 web servers here, all of them would be actually connected to this backplane right here, and this is the common place which is going to be used to send out or basically broadcast the messages or any notifications to all the connected web servers. So in this case, if this web server is generating a notification or a message, it would not directly send it to the connected clients. It would actually first send it to the backplane. And once the backplane receives this notification or message, it is then going to send it to all the connected web servers. And then after that, the web servers would send them to their connected clients. And in this way, it ensures that the message or notification is not limited to only the connected clients of that specific web server. It is received by all the connected clients to that specific web farm, for example, right? So let's take this step by step. So for example, there was a notification that this web server had to send. So the first thing it's going to do is going to notify the backplane right here. And what the backplane is going to do right here is going to broadcast this to all the connected web servers right here. So the first message received by the backplane, and then the backplane sent it to the server 1 and then to server 2 right here. And then after that, these specific web servers sent that message to all the connected clients in their scenario. So in this case, unlike the scenario that was here, if for example there's a group chat going on, as I mentioned earlier, all these clients would not get a consistent experience or a view. But in this case right here, if there's a group chat going on, all the clients would have a consistent view. They would be notified instantly of any update or any new message that comes in. So that is the main benefit of introducing a backplane into the scenario. But now we're gonna see what are the limitations that have been seen with a backplane scenario, and what are the possible options that we may have. Okay, so as I mentioned earlier, bottlenecks with SignalR Backplane. So these are the main bottlenecks that are seen with the SignalR Backplane, and these are also the opportunities that any possible candidate can be marked on to be used as a backplane in the SignalR scenario. So the first one is latency and throughput. SignalR Backplane needs to have very low latency and high throughput. And let me explain what low latency means. Latency basically means the time that a SignalR backplane or a backplane takes to process a message. Once it receives it, the time it takes to process that message and then broadcast or send it to all the connected web servers in this scenario. That is latency. So it needs to be very minimum. Basically what this means is as soon as it gets a message, it needs to quickly send it to all the connected web servers in the web farm, for example. And then the throughput is the total number of messages that it can do in a certain time frame, and it can be 1 second, 10 seconds, or even 100 seconds, depending on whatever is the measuring scale that is present here. Usually in an on-prem deployment environment, applications have databases as their backplane, but there are a few limitations with the database. Databases are generally slow. They're unable to scale out, and they usually choke under high transactional load. So they're slow, and then they are unable to scale out because it's a single server, and then there's a backup, for example, if that's a scenario. But it's a single server, and there's a certain limit to which it can process a number of requests coming in. After that, it will start to get overwhelmed by these transactions, and it would actually start to affect your application. So you can basically scale out the number of web servers within your environment to handle increasing coming load to your web farm. But when those applications have to get in touch with a database, for example, in the back, that's where the bottleneck is, and that's where your all of your applications take a hit on the performance part. The next thing is guaranteed delivery of messages. So SignalR Backplane must be reliable, and it should ensure a guaranteed delivery of messages. There should not be a scenario where a message was not delivered, or it was missed, or due to whatever scenario it was never received, right? So it needs to have a guaranteed delivery of messages. Another one is databases. As I mentioned already, database can choke down under extreme load, and they're a single point of failure as well. So if that specific server goes down, your whole environment basically goes down. That should not be the scenario. There should be some sort of efficient backup that can, in an emergency scenario or whatever scenario, it should be able to recover very quickly from that specific scenario. The third one is it needs to have high availability. So a SignalR needs to be highly available due to whatever scenario. If there's any sort of issue, the whole system should not go down. There should be some sort of backup that can help continue the operations. It should not be affected very quickly. If there is a situation, there should be some sort of a backup that should be able to maintain everything or keep the environment going till everything can be restored back to normal. And this can be in planned scenarios where there's some sort of maintenance planned, or unplanned scenario where anything could go wrong. So if we look at this diagram right here, we can look at the scalability bottleneck with a database, and that's exactly what I was explaining to you guys right now. Right here, you have all your clients that are connected in through, and their requests are rerouted through the load balancer, and this is your web farm. As I mentioned earlier, you can scale this web farm. You can increase the number of web servers, and that would actually in turn increase the total number of requests that your environment can basically take at a single point in time. But the actual issue relies when these web servers have to get in touch with the backend, with the database at the back, and it could be for whatever scenario. It could not only be just for SignalR, or it could be any other scenario as well. Okay, so I'm going to present the solution. The solution to this is an in-memory distributed cache as a SignalR Backplane, and I'm going to, as I mentioned earlier, I'm going to be using NCache as a sample product for that. And NCache is an open source product. We have different versions, and you can evaluate those if needed. So let me explain what an in-memory distributed cache is. So basically, in-memory distributed cache is a cluster of inexpensive cache servers. So you have different cache servers hosting the very same cache. It is logically a single unit, but underneath there are multiple servers that are hosting this cache. And once they're together, once there are multiple number of servers, they're not only pulling in the total computational power resources together, but they're also pulling in the memory resources. So as you add number of servers, you basically scale out on the number of transactions that can be done in a specific set time, and also the total number of data that can be stored. Right now I'm explaining generally in terms of what is an in-memory distributed cache. I'm not talking in reference to SignalR, but I will map all these features with the bottlenecks that were initially discussed. So initially I'm just explaining, and this could be a distributed cache could be used for an object caching scenario or a session caching scenario. It's for all of those right now, but I will map these features over there as well. So you have multiple servers pooling their memory resources and also the computational power resources together. And the next thing is a cache synchronizes across the servers. So with reference to NCache, what it does is, even if, for example, you have 4 cache servers hosting the very same cache, and there's some new data that gets added to the cache, there's a distribution map which gets updated as soon as the data gets added or updated or even removed. It gets updated. So at any point in time, even if one of the servers, one of the cache server gets a new item added to it, all the other servers within the cluster would automatically and instantly be notified that there's a new item added to the cache now. So it ensures that the whole environment stays in sync with each other. And there are different topologies through which data is kept within the cache, and that's a separate discussion. But generally talking, as soon as an item gets added, all the servers in the cluster get notified about a new item that is being added. So that way it ensures that it is immediately visible to all the servers present within the same cluster. The third one is linearly scalable. As I mentioned to you earlier, these are multiple number of servers which are pooled together, and there's no limit to it. You can add as many servers here as required, and the cache would adjust automatically. It basically increases total requests that it can handle. It also increases the total number of data that can be added to the same cache. So it's all linearly scalable. So as you scale your application tier, you can also scale your caching tier, and that was one of the bottlenecks with databases. You can never scale your database environment. But with this, you can definitely scale your cache server, your whole cache, and in that way, you can actually increase your application's performance as well. The fourth is data replication for reliability. So as I mentioned to you earlier, these are multiple servers which are pooled together. So depending on the topology, there are replications being maintained on other servers. So even if one of the server goes down, there's the data of that lost server is replicated on one of the other servers, right? And that would automatically start the recovery process, and it would bring up that data and put it back into the active partitions of the cache. If we're talking for partition of replica, for example, that's the topology of NCache. So it would automatically bring that data and add it to the same cache. So data is not lost even if one of the server is gone. And if there are any clients connected to that server which was lost, they would automatically detect that, and they would fail over their connections to the remaining servers present within the cluster. And this is one of the another key things, that it's not a single point of failure. So if you have multiple number of servers, as long as you have one cache server remaining in the cluster, your cache would be functional and would respond to requests that are coming in. So even if one of the server goes down, the whole cache does not go down, your environment does not go down, and your applications continue to work just fine. So now I'm going to map all these things that I've just discussed onto the bottlenecks that were previously discussed for SignalR Backplane. So if you go right here, the first one was latency and throughput. So latency, as I mentioned earlier, is the amount of processing time. So if you have a lot of servers generating a lot of messages, and so those requests are coming in right to the backplane, and the backplane in this case is NCache. So if you feel like your environment is getting choked, you can add number of servers, and that would actually increase the total capacity of handling the number of requests.
Cal, I have a question here.
Yeah.
How complex is it to set up NCache as SignalR Backplane?
Right, it's quite easy, and we have a very detailed and explanation of a document which helps you work through it. And I'm going to be going through exactly that in the hands-on demo part, and I'll be referring to this question there.
Okay.
Okay. So coming back to the bottlenecks that were that are generally observed with the SignalR Backplane and mapping NCache or a general distributed cache features on it. So as I mentioned earlier, your latency gets really low as you have multiple number of servers which can actually handle the requests that are coming in. So that would automatically decrease the latency, and obviously it would also increase the throughput. As you have low latency, the throughput will automatically go down, and in general your overall performance would go down. The second is guaranteed delivery of messages. So within the NCache algorithm and logic, the client to server, there are a lot of checks being maintained. So if, for example, a client tries to connect to the clustered cache, and if for whatever reason it is unable to deliver that message, there are internal retries that are implemented. So the client, NCache client, automatically tries to reconnect to the cache server, and this is all configurable as well. You can configure the number of retries, you can configure how long it should retry, all of those. So basically you can ensure that your client is able to connect to your specific cache cluster in this case. And even while a connection is already maintained and it is found to be broken, again, in that specific scenario, it would ensure that the message actually gets delivered. The third one is high availability of the backplane, and this is one of the key things that I initially mentioned was you have multiple number of servers hosting the cache. So if one of the server goes down, it does not mean the whole cache goes down. your other servers are going to be able to handle the load that is coming in. They are going to have the connections of the clients fail over to the remaining servers present within the cluster. So in this way, it ensures high availability. It ensures that the messages are get delivered, and then lastly, it ensures that the performance is greatly increased. As you add as you scale out on your application tier, you can also scale out on the caching tier.
Okay, very good. Cal, another question. How much performance improvement can we get if we use NCache as SignalR Backplane in comparison to databases? Are there any benchmarks, numbers that you can share?
Okay, in specific to SignalR, I may have to look these benchmarks up, but generally, in terms of the benchmarks in terms on the number of transactions that are being done, I can definitely show those later on. And
Okay.
there was a screenshot right here, so I can show that. Okay, right here. So these are the scalability numbers, and they're specific to the topologies as well, but these are generally ones. So as you add number of servers, you actually increase the total number of transactions that can be done, and transactions are broken down into reads and writes per second. So these can definitely be compared with databases because it's not scalable. So there would become a time when the cache would actually come up as compared to the database.
Okay, thanks.
Okay, so coming up here, this is a typical deployment of NCache. So we recommend having a separate caching tier, as you can see in this, but you can also have the cache on the very same servers as your application. So that's also supported, but we recommend having a separate caching tier, and I'm going to be talking in reference to that. So this is your application tier where you have all your application servers, and this is your caching tier. Again, it's linearly scalable. You can add as many servers here as required, and then all these servers, as I mentioned earlier, they don't require any specific hardware. They don't require any high tech, or they're inexpensive servers. And with NCache, there's the only prereq of NCache is .NET 4.0. Otherwise, NCache is supported on all Windows environments. The recommended operating systems are Windows Server 2008, 12, and 16. Whichever has .NET 4.0 with it, you can definitely work with that. With NCache, there are two different kinds of installation types. There is the NCache cache server installation, which can actually host a cache, and then there's a remote client installation. Remote client can have a local, or basically standalone cache, and they have the libraries and resources for clients to be able to connect to remote clustered caches. And as I mentioned earlier, the clustered caches are the one which are hosted on cache server installation. So this is a typical deployment. All your applications are connecting to the database, to the caching tier, and the caching tier is also connected to the database in the back. We have features through which it is supported as well, and this can be used. So NCache can not only be used, for example, as a backplane for SignalR, but it can be used for data caching, session caching, and we have other webinars and documentation which help you configure those if you guys are interested in that. Okay, so now this diagram basically shows NCache. It is deployed as SignalR Backplane. So it is quite similar to the same one which we were initially looking at. So this is your web farm right here, and you have, let's assume, a load balancer up here through which all the client requests are being rerouted. So instead of a plain backplane right here, NCache is used as a backplane right here, and you have a number of servers here which are linearly scalable, as I mentioned earlier. In this case, we have three cache servers right here. So in this case, this web server right here generated a notification or a message, and it sent this notification to the backplane, and in this case the backplane was NCache. What NCache would do, it would in turn publish this, basically broadcast this notification to all the subscribers of this very message right here. So once this message was received by NCache, it was then broadcasted to all the connected web servers in this case, and after that it was then sent to all the connected clients. So in this way, it ensured that all the connected clients had a consistent view and experience while working on their application, and NCache was plugged in as a backplane in this case. And these are the numbers that I've already talked about. So as you add number of servers, basically, you can see that there's a linear improvement in the number of reads and the number of writes that are being done right now. So it's linearly scalable. There's no stopping to it. So you can add as many servers here as required within your environment. So I'm gonna go to the actual hands-on demo part, and this is where I will be demonstrating how to create a cache. I'll be quickly skimming through it because that's not part of the agenda, but we do have other webinars in which we're covering each and every detail, and we're talking about the best practices and other general recommendations when you're creating cache or configuring and setting up different settings related to the cache creation process. So the first thing that you need to do is you need to download a copy of NCache from our website, and then you need to install it within your environment. I have two machines which have NCache already installed on them, and I'll be using that. So I'm just going to log into those. I have these logged in, demo 1 and demo 2 right here. So with NCache, there comes a tool, NCache Manager, through which you can basically create and configure and work with and manage caches basically. So this is when you open up the NCache Manager, this is the view that you get. If you right click on clustered caches and click on create new clustered cache, this is the view that you get. So all caches need to be named. I'm going to go ahead and give it a name, SignalR cache. All caches need to be named as I mentioned earlier, but this is not case sensitive. You can use it in any way. If I click next, these are the 4 topologies, and we have this covered in other webinars. This is the replication strategy. I'm going to keep everything default, and I'm just going to configure the 2 cache servers that I've just shown you, demo 1 and demo 2 right here. Just going to click on next. This is the port on which the cluster communicates. So basically NCache uses TCP IP ports to maintain its connections. So I'm just clicking next there. This is the cache size. If you're using NCache for SignalR and as a backplane for SignalR, it doesn't really matter the size because it's just a queue that's going to be maintained within the cache, and as soon as that message gets sent out to the connected clients, is going to be removed. So besides a single item, there's nothing more that is going to be stored within the cache. And this single item, I'm going to talk about it later on when I look at the actual sample that comes with it. So I'm just going to keep everything default right here. I'm going to turn off evictions because I don't want anything to be removed even in the case that the cache gets full. I'm going to check this box, which is going to start the cache on when I click finish. I'm just going to click on finish. So that's how easy it is to create a cache within your environment using NCache. So I'm just going to wait for the cache to start, and then I'm going to add a remote client to it. That's going to be my personal machine right here. Okay, so the cache is started, and we can see right here there's 0 activity going on at this point, but that's because we have no other application basically connected to this cache right now. So I'm just going to go ahead and add my machine as a client node to it. To add a client node, just right click here and click on add node. I'm going to give it my personal machine's IP. It can be a machine name or an IP. Both are supported. Just click on finish. Yep, right here we can see that my machine is added as a remote client right here. So I'm just going to quickly test this cache to see if everything is working just fine. Actually, before that, let me show you the monitoring tool of NCache. So if you're using NCache as a backplane, you can use the monitoring tool, which is an excellent tool, which gives you quite a bit of detail of exactly what is going on in the cache, helps you debug issues, and helps you get a lot of details around how the performance is going on and how, from where and where the actual hits are being taken in, and what can be improved overall. So if I just right click on the cache name right here, I can click on monitor cluster. This opens up an NCache monitor tool, which can be used to monitor the cache. So it shows you a bunch of different things right here. If we just open up server dashboard right here, it gives me a pretty good view of exactly what is going on in the cache, different graphs. This is the CPU graph, this is the total network that is being used, this is the cache size, this is the total requests that are coming in. So it shows you quite a bit of different things that can be used and looked at when you have a working environment right here. And what I'm going to do is, from my personal box right here, I'm just going to run a stresses tool application to simulate some dummy load onto the cache. This tool comes installed with NCache, so I'm just going to look for it. Just going to type str, it's going to come up, stresses tool.
So Cal, while you're pulling that up,
Yeah.
could you answer what sort of underlying framework NCache uses for SignalR?
Okay, so basically, NCache is using the PubSub model. So all these clients, which are basically web servers, they're connected as publishers as well as subscribers. So any of the clients can actually publish a message as well, and all the connected clients are also subscribers, so they'll get notified about it as well. So it's basically PubSub model. We have a complete separate implemented API as well as other whole framework of just PubSub. But underneath SignalR, PubSub is being used. You can use it separately as well. Okay, so I'm just gonna open up Stresses tool. So this is the location where it is actually. It is a C program files and cache bin tools. So we'll just look for a Stresses tool right here. Yep, right here. Just gonna open up instance of the command prompt. Just gonna drag and drop it here. Okay, actually I hit enter too quickly. Let's do a clear the screen. Okay, what I'm going to do is I'm going to type, oops. Okay, so this is Stresses tool. I'm going to give a space, give the cache name. The cache name was SignalR cache. I'm just going to hit enter now. So if I go back to this view right here and open up the statistics, we should see requests coming in to this right now. Let's see if there were no errors. Okay, I see some requests coming in now, and right here you can see that there are a bunch of different requests coming in to both the connected both the cache servers right now. So this seems like everything is actually working just fine, and it's taking on requests as well. If you open up the monitoring tool right here, you can see that there's one client connected here, one client connected here, and if we look right here, we see that there's a big jump in the total number of requests that are coming in. You can also see that the memory graph is taking a bit of hit as well. So if we verified actually that it's working, so I'm just going to stop this tool now. Just going to go back to the NCache manager. I'm going to right click here. I'm going to clear the contents of this. So now that we have got a cache set up and it is working just fine, we've tested it, it seems to be working just fine. So what I'm going to do is I'm going to open up a sample project that comes installed with NCache, and I'm going to follow the documentation that is published on our website step by step on how you can basically configure it. You can configure your own ASP.NET application to use NCache as a backplane. So if I just go right back into the installed directory of NCache that is in C, program files, and NCache right here, I can go into the samples folder and then into .NET. And right here, if we just look for right here, we can see that there's a SignalR chat sample given here. So this comes installed with NCache, and this is the very same one that I'm going to be using in my demonstration right here. I've got it already opened up right here. So I'm going to open up the documentation, and this is the documentation that gives you a step-by-step view of how you can configure it within your own specific environment. So if we just go right here, so the first thing that you need to do is you need to install the NuGet package, and let me show you exactly which NuGet package we're talking about. So if we just right click here and click on manage NuGet packages for the solution, okay, right here, if we go into the browse and we're browsing on nuget.org, I'm just going to search for NCache. Okay, right here, if we just go a little bit down, I think I may have missed it. Okay, this is the community SignalR. Okay, let me just lower it down so that I can find it. The name of the NuGet package is elasticsoft.ncache.signalr. So it should come up here, right here, elasticsoft ncache.signalr. So this needs to be installed within your application. I don't need to install it at this point because I have an installation of NCache and I've already referenced the required libraries. But if you're not using the NCache installation, you can definitely just add this as a NuGet package. You just need to install it within your within your application project. The next step here is to include these two namespaces, alachisoft.ncache.signalr and then microsoft.asp.net ASP.NET.SignalR. So these need to be introduced in the startup.cs. I'm just going to be following the sample project, but you need to do it in reference to your own specific setup. So if you go into startup.cs right here, go right to the top, we can see that these two are already referenced here, alachisoft.ncache.signalr, microsoft.asp.net ASP.NET, .SignalR. So it's already added up here. Let's go look at the next step. So now we need to modify the web.config. So we need to add these two specific keys right here. Let me explain what these are. The first one, which is goes by the name cache, is the actual cache name. So you need to give it the cache that you're going to be using it, which is going to be on and running, and you need to use this. The second is the event key, and this is what differentiates between multiple. So if you have the same cache being used as a medium, as a backplane for multiple different applications, right? So this is what differentiates it. So it opens up basically a channel within the cache through which all the applications which have the very same value would be able to get notified. So if there are two applications which need to communicate with each other, they need to have this value to be the same. But if there are different applications, you can change this according to your specific environment. So right now it is set to chat right here. And if we go back into the sample project right here, and we go into the web.config, we can see that it is set up right here. The cache name is different, and what I'm going to do is I'm going to change it to the cache that we have created, and that is SignalR cache. As I mentioned earlier, this is the cache name is not case sensitive, so you can go with just this. So I'm just going to go ahead and save this. Let's go back right here. So these these things are basically, these are the overloads that can be used. I'm going to show what I'm using in my environment. Initially, you're just registering two string variables, which are going to be taking the values that we have initially stored within the web config. That is the cache name as well as the channel, for example, name. And then this is where you specify that NCache should be used. So basically, it's just 2 to 3 lines of code that needs to be introduced within your application, and you should be good to go to use NCache as a backplane within your application. And there was a question initially which was referring as to how difficult it is to configure NCache to be as a backplane for your specific application, and it's quite easy. So there's just 3 lines of code that needs to be introduced, and you should have NCache to be as a backplane for your specific environment. And if I go back to my project right here, go to startup.cs. Right, we have the specific same code, and there's just some checks present here just to ensure that the values are actually in place. And then right here we have this this call right here, which introduces NCache to be used as the backplane for this. So what I'm going to do now is I'm actually going to run this application and open up a couple instances of it so that I can show you how this chat room is working right now. So I'm just going to click on run right here, and it should open it up. Okay, so the build is done. It should open up now. Okay. Okay, just waiting for it to load it up. Usually doesn't take this long, but it is right now. Okay, in the meantime, let me just quickly go over the slides that we are using. So I think it's opened up in the back. Okay, so if I just click on default.html right here, there should be a pop-up here which asks me for the name that I'm going to be using. So since this is a chat room, there are you need to register yourself with the name. So when you send a message, the other recipients should know from exactly who this message is coming from. So right here, it is asking me for my name. I'm just going to go ahead and give the name Cal, and I'm going to write hello and try to send it. In the meantime, I'm just going to open up another instance of it right here, and it should open up. Still hasn't sent it, but let's see. Let's verify if the cache name was correct. If you go back into web config, it is, oops, I think I got the name wrong. So it's SignalR cache. I may need to run it again. So I'm just going to go ahead and stop it. Going to close these instances. Obviously, since the cache name was not correct, these would not work. So I need to run these again. Okay, so let's verify one more time. SignalR cache. It is correct now. It is stopping the instance at this point. Okay, I'm just going to run it one more time. This should be quicker because it's already done. Guys, in the meantime, if you have any questions, please feel free to ask away. Okay, so the build is done. Now we're just opening it up. Okay, this is opening up.
So Cal, I have a question here. Does this work for SignalR core as well?
Yes, it does work because NCache does support core .NET Core as well. So it does work with that. Yes.
Okay. Another question is, what messaging capabilities NCache offers other than SignalR?
Okay, so as I initially mentioned, underneath SignalR, the whole implementation as a backplane, NCache is using PubSub model. But other than that, you can use PubSub as separately as well. It doesn't always need to be used with as a backplane for SignalR. But otherwise, we have events, and events can be data-driven events, or it can be specific user-defined events as well, with which you can basically notify other applications of a certain event, new item gets added, updated, or deleted, and we have these features. Then you also have the continuous query feature. So with that, you can specify a certain result set within the cache, and if any update gets done on that specific result set, and it could be multiple items within the very same cache, and any of them get updated, it is going to be the client that requested for it is going to be notified about it. So these are other ones that are present as well. So I've just clicked on the default one. It should ask me for my name now. Just gonna wait for that. Okay, so I'm gonna give it the name Cal, and hopefully it should work. So I'm just gonna type hello and try to send it right now. Meantime, just gonna copy this link, paste it right here. Oops, did not open it. Okay, prompting me for the name. I'm just gonna give it the name Nick. Okay, right here we so here from here I sent a message with saying hello, and it was received here as well. So this is a hello from Nick. So I'm just gonna type that hello from Nick, and I'm gonna send it. So right here, Nick sent this message, hello from Nick, and if you look back into Cal's view, we can also see it come up here as well. So we can send multiple messages here as much as we want, and they would be received to all the connected clients to this specific scenario. So we can see that Cal sent a bunch of messages and they were received on Nick's view as well. So they get updated automatically if you just send one last one from Nick as well, from Nick, and you just send it out. We can see it came up from Nick, and from in this view as well, we can see right here. So if we quickly look at the cache that we created and which is being used by it, we can see there's one item added here. And as I mentioned earlier, only one object gets added. The rest is just a queue that is temporarily being maintained while it's being transferred. So if we use a tool within NCache, which is goes by the name dump cache keys, it's going to dump the keys that are present within the cache. So I just want to quickly show you, and we give it the name SignalR cache and hit enter. It's going to pull up all the items that are present within the cache. So at this point there are only one, and we can see there's an item placed here with the name chat, and this string value is the exact same one as we configured within our application against the value of event key. So this is the common key that needs to be used within all of your applications that need to use this specific channel to send and receive messages. So this needs to be the same all around, and this is what exactly what is going to ensure that all the connected clients or connected web service to this specific cache are going to get notified regarding any such thing that's happening. So that's how easy it is to have NCache as a backplane within your application. If I quickly skim through what we have already discussed right here, let me just quickly finish the last screen and last presentation slide here. Is that NCache underneath is using the PubSub model. So you have client applications connected, which can be .NET applications or Java applications, and they're connected as publishers and subscribers. It goes both way. So any application sending any connected client sending a message gets received to all the connected clients, and that way it ensures that all the messages are actually received by all the connected clients. So if you quickly skim through over what we have discussed in today's webinar, is that we discussed about SignalR as a technology, what it is, and how it can help in different scenarios where there's a dire need for it, because the applications cannot wait for the client to actually send a notification, and only then they can respond with their respective data. They want the clients to be notified automatically or updated with the updated data pretty quickly. So we discussed what SignalR is, how it basically works, what are the different use cases that are possibilities, and where actually SignalR is currently being used as well. So they're not just future use cases, there are current use cases as well, and how scaling our SignalR app can have some sort of issues with consistency and consistent view and consistent experience, and how SignalR themselves have introduced the backplane concept through which they can ensure that all the connected clients get a consistent view and they get notified immediately of anything that's going on within the cache. Nick, there's a question?
No, continue, please.
Okay, so then we discussed the bottlenecks associated with the SignalR Backplane. We discussed these three main points, and these, as I mentioned earlier, were also the opportunities which any solution could take. And the solution we talked about was an in-memory distributed cache. In this case, it was NCache, and we mapped the different features, different things that NCache possesses over what a SignalR Backplane really needs. And NCache mapped onto them perfectly, and it was an excellent use case, excellent candidate basically to be a backplane for a SignalR application. And we discussed about NCache, how NCache can be used. We discussed the scalability numbers, and we also went on to the hands-on demo of the sample project that comes installed with NCache and how it can be used. And then there's this documentation right here, which helps through each and every process of this configuration. So I think that's about it from my end. Nick, over to you.
Thanks, Cal. That was very informative. If anybody has questions, kindly let us know, or you can type those questions in the questions box. Just to recap, the NCache solution is available to download from our website, www.alachisoft.com. We have the community edition, the open source version, as well as the enterprise edition that you can download and take a look at. Enterprise comes with a 60-day trial period that you can use to test out before purchasing, and open source is, of course, free to use. If there are no questions, I'd like to thank everybody for joining us, and thanks, Cal, for your time, and we'll look forward to seeing you in the next future webinar. Thank you, everybody.
All right. Thanks, Nick. Thank guys.